see by the dawn. Words have lost their meaning, but we're carrying on, and I believe.
Hello, and welcome to the practice problems video on the section on circles. Okay, here's problem number 1. We're going to practice finding the distance between these 2 points here. Okay, so let's say 3, 3 is our x2, let's actually call that x1, y1, okay? And negative 3, negative 2 is our x2, y2, okay? So to find the distance, the formula is given by the square root of the sum of the squares between the x values and the y values, okay? So the difference between the x values are, let me just write out the formula here first, okay? And this is going to be y2 minus y1. So if we just plug in our values, we get d is equal to the square root of x2, negative 3, minus x1, a 3, squared, plus y2, negative 2, minus y1, 3. And so if we simplify this, we get the square root of negative 6 squared plus negative 5 squared, which is equal to square root of 36 plus 25, which ultimately equals a 61 inside. Okay, so this is our distance, and now let me put a twist on it. Well, not really. We're just going to flip things around. And I'm going to say, okay, how about if in the beginning I labeled these differently? What if this was like x2, y2, and this was x1, y1? So let's try that on the next slide. So we have 3, 3 is going to be our x2, y2 now. And negative 3, negative 2 is going to be our x1, y1. Okay, so now let's find the distance between the points. It shouldn't change, so let's just verify that. So if we have x2, 3, minus a negative 3, okay, squared, plus 3 minus a negative 2 squared, this turns into the square root of positive 6 squared plus positive 5 squared, which again is going to be equal to the square root of 36 plus 25, which gives us that positive square root of 61. So it is indeed the same. So it doesn't really matter in which order, or which one you make to be your like x1, y1 and x2, y2. It'll come out the same way. Alrighty, here's problem number 2. We have write an equation of the circle centered at 7, negative 2 that passes through the point negative 10, 0. Okay, so we're given our center, which is good. So our center is 7, negative 2. Okay, and now we need a radius, right? So what is our radius? Those are the only 2 things we need in order to make our standard equation of a circle, right? So what other information are we given, though? It says it passes through this point, right? So what is the radius again? So the radius is the distance between the center of our circle and any / all points on our circle. Points that lie on our circle, right? So what we could do to find our radius is actually take the distance, we'll apply the distance formula between our center, which is this, and any point on our circle, and they actually gave us a point, which is already on our circle, right? So what we're going to do is find the distance between this center and this point on the circle, okay? So if we do that, let's say we just have 7 minus a minus 10. So that's the difference between our x values, right? Then we have plus negative 2 minus 0. Okay, so we're just going to get that the radius is equal to the square root of 17 squared plus a negative 2 squared. Okay, so that would be the same as saying 284 plus a 4. So this is going to give us the square root of 293. That is what our radius is. Okay, so now we have our center, which was given, and we have our radius, which we just figured out. Okay, and now we'll just plug it into this formula here, or for this equation for our circle. X minus h squared plus y minus k squared. So if we plug in our radius, we get square root of 293 squared is equal to x minus h, that's the x coordinate of our center, so that'd be a 7, plus y minus a minus 2, so that'd be like y plus 2. Okay, and we can just rewrite this simply as 293, well, let me write it 2 simply. 293 is equal to x minus 7 squared plus y plus 2 quantity squared. Okay, and that would be the equation of our circle given the information at the top.